short video, we're going to talk about how to calculate the voltage drop across a resistor. I'll give you 3 examples on how to calculate voltage drop in a resistor installed in circuit. Let's start. This is the electrical symbol for battery. And that is for a resistor. Now this is the positive terminal of the battery. And here we have the negative terminal. On the battery, we're going to use a 6 volt of battery. Let's give R1 a value of 4 ohms. What is the voltage drop across R1? This is what we need to do to find the answer. To calculate the voltage drop across a resistor, we need to know the resistance and the current flowing through the resistor. First, we need to calculate the current flow in the circuit. How can we do that? Well, due to we are using only one resistor, this is a series circuit. The reason why it's called a series circuit is because the current has only one path to flow through these resistors. Now, before we can calculate the current in a circuit, we need to know the value of the resistor. In this example, resistor value is 4 ohms. Now to calculate the current flowing in a circuit, we're going to use the voltage of the battery and the current flow in this circuit times the resistance. So this comes from his own Ohm's law. The V equals IR. So the voltage of the battery is 6 volts. The resistance is 4. 6 divided by 4 is 1.5. So the current flow, and in this circuit, is 1.5 amps. Now once we have the current, we can now calculate the voltage drop across resistor. Now we're going to use Ohm's law, again. V equals IR. We have a current of 1.5 amps times a resistance of 4 ohms. So that gives us a voltage drop of 6 volts. Why we get also 6 volts same as our battery input voltage? It is simply like this. If you're using multimeter and you test the voltage drop across resistor and you put test probe at 2 terminal of resistor, it is just like you just test the voltage output of the battery. Now let's try another example of 2 resistor installed in a circuit. This is the electrical symbol for battery. And this for a resistor. This is the positive terminal of the battery. And here we have the negative terminal on the battery. We're going to use a 12 volts. This is going to be R1, and this is going to be R2. Let's give R1 a value of 4 ohms and R2 is going to be 6 ohms. What is the voltage drop across R1? And what is the voltage drop across R2? In order to calculate the voltage drop across a resistor, we need to know the resistance and the current flowing through the resistor. First, we need to calculate the current flow in the circuit. So how can we do that? Well, first we need to know what type of circuit we have. And this is a series circuit. The reason why it's called a series circuit is because the current has only one path to flow through these resistors. Now, before we can calculate the current in a circuit, we need to determine the total resistance for resistors in series. The total resistance is this sum of all the resistors. So in this sample, it's simply 4 plus 6, which is 10 ohms. That's the total resistance of this circuit. Now to calculate the current flowing in a circuit, we're going to use the voltage of the battery and the current flow, and in this circuit, times the total resistance. This comes from his own Ohm's law. The V equals IR. So the voltage of the battery is 12. The total resistance is 10. 12 divided by 10 is 1.2. So the current flow in this circuit is 1.2 amps. Now once we have the current, we can now calculate the voltage drop across each resistor. Now we're going to use Ohm's law, again. V equals IR. The voltage across resistor 2 is going to be the current that's flowing in a circuit times the value of resistor 2. So we have a current of 1.2 amps times a resistance of 6 ohms. So that gives us a voltage drop of 7.2 volts. Now for V1 is going to be I times R1. So that's a current of 1.2 amps times of resistance of 4 ohms, which is 4.8 volts. So let's talk about what this means. If you were to take a voltmeter and connect it across R1, if you do it properly, you're going to get a voltage of 4.8 volts. If you do across R2, you're going to get a voltage of 7.2 volts. Notice that the sum of the voltage drops in this circuit is equivalent to the voltage of the battery. That the sum of the voltages around a closed loop must add to zero. Now the battery delivers energy to the circuit, so we're going to give it a positive voltage. And the resistors, they consume energy from the circuit. So we'll give it a negative voltage. That's called the voltage drops. So if you add positive 12 with negative 7.2 and negative 4.8, you're going to get 0. So that's how you can calculate the voltage drop across the resistor in a circuit like this. Let's try another example to make practice more perfect. This time there's going to be 3 resistors instead of 2. So we're going to call this R1, R2, and R3. Now the voltage of the battery is going to be 24 volts in this case, and R1 is going to have the value of 2 ohms, R2 is going to be 4 ohms, R3 is going to be 6 ohms. So go ahead and take your time and work on this example. Calculate the voltage drop across each resistor. Feel free to pause the video to try this problem. Let's begin by calculating the total resistance. R1 plus R2 plus R3. That's gonna be 2 plus 4 plus 6. 2 plus 4 is 6. 6 plus 6 is 12. So the total resistance in this circuit is 12 ohms. Step 2 is to calculate the current in a circuit. Because there's only one path for the current to flow, all 3 of these resistors are in series. The current is going to be the voltage of the battery divided by the total resistance of all the resistors in series. So the voltage is 24 volts, the total resistance is 12 ohms. 24 divided by 12. That's going to give us a current of 2 amps. So now that we have the current in a circuit, we can now calculate the voltage drop across each resistor. So let's start with V1. V1 is going to be the current times R1. So that's a current of 2 amps times the resistance of 2 ohms. That gives us a voltage drop of 4 volts. Now let's move on to V2. The voltage drop across our R2, it's going to be I times R2. That's a current of 2 amps times 4 ohms. So that gives us a voltage of 8 volts. Now, to calculate the voltage drop across our R3, it's going to be I times R3. So 2 times a resistance of 6, which is going to give us 12 volts. So now let's add these 3 numbers. 4, 8, and 12. So 4 plus 8, that's 12. 12 plus 12 is 24. And that's a quick way to tell if you perform this problem correctly. The total of voltage drop are equal to the R input voltage.